This lecture is for Stat 220, our statistics class, and today we will be covering Chapter 2, which is summarizing data and tables and graphs. On this first page, I just have some general graphs that you'll see anytime you open Excel or some other package that can create graphs for you. You have all these different options of making graphs. So we're going to talk today about some of the different types of graphs and when you should use what graph, because there are certain graphs to use if you have quantitative or categorical data, different ones that you're supposed to use in each case. So we're going to discuss those here in Chapter 2. So the first kind of chart that we'll talk about is a frequency distribution. So this is going to be a fairly simple chart to create, even though it has kind of a fancy name of frequency distribution. But really all frequency is just the count. Okay, so when you see the word frequency here, just think of the count. So we're talking about the count of how many we have in each group, okay, or how many people said yes, or how many said no, or whatever. So in this example, we have a sample of 40 Kentuckians that were asked what's your highest degree that you've obtained. And so you'll see here, we would go around and ask people, and they would say, my highest degree is associates or my highest degree is a doctorate or whatever. Then we tally all those up and put this into a frequency distribution. What this tells us is just at a quick glance we can kind of see, it looks like most people have their bachelor's followed by master's, and then we can kind of get some idea from that where these degrees are scattered in this distribution. A relative frequency distribution is going to give us a little more information in that instead of just giving us the count or the frequency, we do the relative frequency. The relative frequency you want to think of just as a proportion or a percent of that group. So you're looking at what is the frequency of this group relative to the entire group. Okay, so here we see that 5 out of the 40 people had a high school degree. So 5 out of 40 is 0.125 or 12.5%. So you can write your frequency, relative frequency, as a fraction, as a decimal, or as a percentage. So this decimal is typically what we would call a proportion. Here, doing it as the fraction or the decimal. But usually people kind of like to hear it as a percentage. It makes a little more sense when we create it as a percent to say 25% of people had their master's degree versus saying the proportion of people who had masters was 0.25. That doesn't always make as much sense to people for just trying to explain our data to them. So a relative frequency here, you can see the simple little equation is that the frequency is divided by the sum of all the frequencies. Okay? All right, some graphical representation. So we're going from just doing a simple organizing into this chart into a graphical representation. So we're talking about qualitative or categorical data here at first. And remember that qualitative data is when we put people into groups or into categories, right? And so our categories are going to be words, they're not going to be numbers. So this was categorical data, right? Because these were all groups that people fell into versus quantitative data that would be like height, weight, those kind of things. So a bar graph is our first option. The difference are some interesting things about the bar graph is you want to make sure there are spaces between the bars, and we'll talk more about that when we get into talking about a histogram. But to create a correct bar graph, you should have these spaces here, okay? So you notice that high school doesn't just go straight into associates. There's a space in between each of these, okay? So you want to make sure you do that. And you're going to use this when you have one qualitative and one quantitative variable. So the qualitative variable is going to go down here on the x-axis, the horizontal axis, right? In our case, we were doing degrees, what your highest degree obtained was. So that's going to be our qualitative data. The quantitative variable is just our frequency or our count. So over here you see we did this with frequency, but we could have also done it with our relative frequency or percentages, but we just chose to do the frequency or the count. So we can see very quickly that the bachelor's degree category is the highest of any of the other ones we have, and then we can kind of see how they go from there. Now, a Pareto chart is still a bar graph. You see it looks pretty similar to this, but the difference is that you actually order the bars or the categories from largest to smallest. Now, in this situation, it really doesn't make a big difference which one you do, because either way, because we have just a few number of categories, it's easy to see on either of these, which was the largest, which was the smallest, etc. However, if you have lots of categories, for example, look at this. If we're looking at unemployment rates by state, so we're looking at all the 50 states, so we're going to have 50 different bars. Now, I might be able to identify which one's the highest or the lowest, but if I wanted to know, like, for example, where does Kentucky fall in this list? Well, if I look up here, actually, Kentucky's not even marked. It would be in here because they're alphabetical, right? But just looking at the bar, I can't really tell, is Kentucky good or bad? It looks like we're somewhere in the middle. I can't really tell. But if I rate this like a Pareto chart, so from highest to lowest, now I can immediately see, oh, New Mexico has the highest unemployment, North Dakota has the smallest or lowest unemployment, and here's Kentucky somewhere in the middle. So this gives me a better idea of how the data's distributed by state instead of this where I just kind of look at it and it's like I really have to investigate closely to be able to tell what all the percentages are. So a Pareto chart might be a good option if you have a lot of categories that you're looking at. Some other things we can use for categorical qualitative data is a pie chart. So a pie chart, of course, looks like this. It's going to be our circle graph. You're going to use this again when you have one qualitative, one quantitative variable. But it does have to show parts of a whole. So our categories have to add up to 100%. So everybody has to be included in at least one of these categories and only one of these categories. So if we had asked, instead of just your highest degree obtained, if we had said, what degrees have you obtained? Well, like me, for example, I've earned my high school and my bachelor's and my master's, right? So I would fall into three groups. But I still just count as one person, right? So then if we look at how many people we surveyed and then add up the number of people in each group, we would end up with a total that's greater than the number of people that actually participated in the survey. In that case, our pie chart would be more than 100%, right? Because since I fit into three categories, I would count as three instead of just the one person I am. Okay, so you want to always check that the data you're looking at adds to 100%, and if that's the case, then it's fine to use a pie chart. If not, then it's better just to do a bar graph. Side-by-side bar graphs are another example of bar graphs. These are nice, like here we're breaking it down by male and female, so that can just kind of show me, okay, I know the highest degree obtained is a bachelor's, but how does that compare male versus female? Is there a difference in the number of males that achieved an associate's versus female or whatever? Okay, so we could look at something like that. So that's when you want to break it down by some other category. So organizing quantitative data, so this of course is when we're doing numbers. Now you see again here, we do a frequency chart or a relative frequency chart the same way. This number of TVs, what I actually did for this example was I asked the students in my class how many TVs they had. So you'll notice that none of them said 0, none of them said 1, 4 of them said they had 2, 7 said they had 3, 7 said they had 4, 7 said they had 5, and 2 said they had 6. So this added to 27 students that I had that day. This would be our relative frequency, and this column should add up to 1 or 100%, depending on if you're doing decimals or percentages. Now what this is for is this is just showing you if you have a large number of different quantitative responses. Like here, our only possibilities were just 0 to 6. After that, nobody had more than 6 TVs. That's not that many groups. But here, we're looking at days to maturity of short-term investments. These went anywhere from in the mid-30s all the way up to the 90s. So that's going to be a lot of different options for our quantitative data. So we're probably going to have to put our data into groups so that we don't end up with like 60 different bars that we're looking at, right? So what this explains is kind of how to adjust in Excel or in your StatCrunch or wherever you're doing your graphs, how to adjust it so you can kind of make it look nicer. So these two graphs are actually showing the same data. This graph doesn't give us a whole lot of information because all the bars are very similar in height. This one, though, gives us a lot more information. We can see right away that most of these short-term investments mature between 61 and 75 days. We see that very few mature in 30 to 45 days or 91 to 105 days. So that just gives us a better idea about these short-term investments. Stem and leaf diagrams. What you want to remember for these is only use these for small data sets. These are charts or graphs that you're going to be doing by hand, and so they're just kind of a quick and easy way. If you've got some data there, you want to see what the shape looks like, you could use this stem and leaf chart. Now, since we all have, pretty much all of us have access to something like Excel or some other chart producing software, these really aren't as important anymore. They used to be more important when everybody didn't have computers or calculators to do work for them. Because it was kind of a big hassle to create a histogram. But in this case, you could either throw your data into Excel, create a nice pretty histogram, or you could do this stem and leaf just on your own on paper and get a good idea of where the data is falling. So what we do here is the stem is going to be the digit to the left, the leaves are the digit to the right. The leaf can only be one digit. So when you're looking at numbers, so like these numbers, if I'm looking at the number 45, the stem is 4 and the leaf is 5. If I'm looking at the number 1568, the leaf can still only be one digit. So 8 is the leaf and 156 is the stem. Okay, for these, all of them are just two-digit numbers, so you're going to have the first number being the stem, the second number being the leaf. And so what we get when we write out all these numbers here is we notice that we see some sort of shape emerging. And if we were to turn this on its side, turn it this way, where the bars were standing straight up, we would kind of think of it as a histogram. So describing data sets, and one thing I don't think I mentioned back here with the histogram, um, is with histograms, we always want the bars to touch for histograms. So you notice that here we go straight from this bar into this bar. And that's because on the bottom, the x-axis here, this is our quantitative variable. This is a number line, right? So we don't really need a space between this one and this one unless there's no data in between there. Like for this, for instance, here we had no investments that happen to mature between 41 and 45 days. So there is a gap there. But if there's some data in each of these categories, then we want them to all touch because, again, this is a number line. So we don't need to skip or put a space in between categories because we are going just from one number to the next. Describing data sets, this is definitely going to be important going forward. Just trying to figure out how we're going to describe our data because that's what we're trying to do. We collect this data and then we want to do something with it, right? So one of the first things we'd like to do once we graph the data is to get an idea of what the shape is. So we call that kind of describing the distribution of a data set. So the distribution can be described with a table, a graph, or even a formula. We'll talk about that in later chapters, how we can do it with a formula. But for now, if we were to put something in a histogram, we want to look at the shape, the modality, and the symmetry or skewness. So you see different shapes here. We've got a bell shaped like that, the triangular shape. A uniform shape is where basically all the heights of the bars are exactly the same. We don't use the reverse J and the J shape too much, but it is in this graphic, so you'll see it there. Then we have a right skewed and a left skewed distribution, bimodal and multimodal. So underneath all of these is a histogram. So what you would do first is you get your data, put it in a histogram, and then you're just kind of looking for what shape would go over my data. So for example here, you can see that I've got these green bars, but I can kind of draw this black, what we're going to call later a density curve, over this histogram, and that just gives me a quick idea of what the shape of the data looks like. So most of the data falls here, and then we have some of the data here and some here, but most of it is right in the center there. This would follow more of somewhat of a uniform shape, I guess, because so many of the bars are equal. With the modality that we're talking about there, a mode is the category or number that appears most often in a data set, and we talk more about that in Chapter 3. But if something is multimodal, then it has multiple modes, okay? This, that just has one peak there, that would be unimodal, okay? Because there's only one highest bar. Something like this would be bimodal because it has two bars that are the highest. After two, we just go into multimodal. So it could have three or four or five or six or whatever of those peaks there. We also would like to check for outliers. Notice if you have one observation that is much higher or lower than the rest. That might be interesting to figure out, why do I have that one outlier there. Then we've got the one we're probably most the one we're most familiar with. That would be the time series plot, which you can also think of as the line graph that we've talked about in other math classes. And so we use this usually to show some sort of change over time. Now your time could be date, or your time could be days or months or years or whatever, but it's something about over time. And so like this one here was showing, in general, are you satisfied or dissatisfied with the way things are going in the U.S. at this time? So this is something they check. I don't remember if it's quarterly or weekly or how they do this, but you can see over time it's gone up and down, but there's a general, trend going on there. Even though there's lots of little peaks and valleys in here, there's a general trend overall. Like here it was increasing, here it's decreasing, increasing, decreasing, and then it's increasing slightly, but somewhat staying flat. This 9-month average retail price chart, something we like to see with the gas prices decreasing. Now this was at the beginning of the year, so I haven't updated it. It's kind of gone back up just a little, but still not like where we were, this time last year, so not too bad. But anyway, you can see overall the trend is that it's going to go down. Even though you have these spikes here and there is an overall trend. So looking in time series charts, what do we look for? Like I said, we look for the overall trend. So we see here, this is gun sales. The name of this graph is gun sales soar after Obama calls for new restrictions. Okay, so we see that there are lots of peaks and valleys, but overall, this graph increases, okay? You might want to look for, are these peaks always in the same spot? And they are. In this case, we're looking at uh, gun sales, and so this is the start of a year here. So this, when it peaks there, is around Christmas time, and then again around, I think they said around Valentine's Day. Strange, but that's just how it is. Here is Christmas time, so you see these spikes happen pretty much every year. Some of these special dots here had to do with certain mass shootings or things that went on um, in time. Okay, so like 9/11 is on here. We've also got this was, I think, the San Bernardino. One of these was Sandy Hook. So we see that gun sales did have an increase after those. This is looking at one family houses that are sold in the US. So we would see that obviously there was that large decrease and now we're on the increase. So what we would talk about here is um, we know that we had a large crash in the housing market, right? So if we're trying to forecast for the future out here, would we really want to use all of this data? Well, probably not, because that's not really what we're expecting to happen right now, and hopefully that's not going to happen again. It might, but we don't really want to forecast for that. So instead, probably what we're going to look at is just this data right here and forecast based off of that trend, okay? Instead of using this, we'll probably just stick with this. And that's something I did when I was forecasting at Fruit of the Loom. There were times that we had big movies that rolled out, like for example in children's wear several years ago when the Cars movie came out. That was a very big seller in our children's underwear. So that one summer, we were constantly trying to make enough of the Cars underwear to ship out, okay? But the next year, of course, the movie was over. We still sold it pretty well, but we weren't going to sell it anywhere near as much as we did the year before. So when I was forecasting for the next summer, I wasn't going to look back at what we did the year before and say, well, I'm going to forecast that we do approximately the same, because we obviously aren't going to do exactly the same as we did last year. Or if we had some big event, like when there was Hurricane Katrina happened, we shipped a lot of underwear and t-shirts and socks and things like that down there for relief efforts because people were buying more and more of them, but we didn't expect that same thing to happen the next year. Okay, so you want to look for, when you are forecasting or looking for trends, you want to identify those things that you don't expect to happen again so that you don't end up forecasting incorrectly. So some graphical misrepresentations of data. These are some common mistakes. The tips for creating a good graph are basically just the opposite of the common mistakes. So looking at some of these graphs, what we talk about is pictograms may look good, but they're never really going to be the best way to display your data. The whole point of doing a graph is to go from this big pile of data that you have to put it into a graph that is easy and simple for the reader to understand. So anyone should be able to look at your graph and immediately know from the title or from the legend, from the histogram or bar graph or pie chart or whatever you've created, exactly what the data is saying. A pictogram like this one or this, when you look at it, it takes you a while to figure out what exactly am I looking at. Now, if I look at this graph just right away, the first thing that pops out to me is this. This is the highest bar, right? So I would assume that must be the most deaths. This is representing the number of fatalities in certain wars and then some natural disasters. So it looks like the Vietnam War is higher than any of the others. However, you go over here to this blue square that's supposed to be like the American flag here, and it says the earthquake in Haiti has 200,000 plus deaths. So each star is actually 4,000 deaths. So that means this one star is about equal to this bar, which is 4,300 deaths from the Iraq War. Now, you can't tell that just by looking at this. The only way you can figure that out is to read closer, figure out, okay, each star is 4,000, so this, if we did have an actual bar graph, this 200,000 would be 4 times the height of this Vietnam War, right? About 4 times. So if we did that, I think that would have much more impact, just quickly looking at it and saying, wow, look how many more people died in the earthquake in Haiti compared to the Vietnam War or the top 10 U.S. natural disasters, etc. So even though this is kind of a neat representation, it's not necessarily the best way to represent the data. This one has a problem because it doesn't add up to 100%, right? So this is obviously an old one now. It's from 2012. But for whatever reason, I don't know if they just put in the numbers incorrectly or if they actually used a pie chart when they should have used a bar graph. Like, for example, when they asked people, who are you going to back in the election, some people may have said Palin and Romney, so they may have said more than one, and that would cause us to go over 100%. So I don't know why it's wrong, but I do know that it shouldn't add to more than 100%. This next one, again, the problem with the pictograph here is it's hard for our eyes to compare anything other than height. So in this case, we're really supposed to be comparing the volume of this gold mine cart there, okay? So you see that the height of the gold is different, and also the size of the cart is different as well. So like looking at these, just to my eye, when I just glance at them, they all look about the same, right? But this is actually twice the production of this one or this one, right? Does it look twice the size? Well, not really, and technically it might be twice as big based on the volume that's created there, but it's hard for our eyes to see that, or to see that this one is about or more than 3 times of that one, right? So it'd just be much easier if we had these as bars, because when you have a bar graph, of course, this isn't going to look great, but with a bar graph, or this is really a histogram, but whatever you're using, it's very easy to see the heights, right? This is definitely the highest and this is the lowest. It's hard to see it when you have it as a pictogram. This is another one, very cluttered, and that's a pictogram. This is a problem because it did not start at 0. Okay, so it looks like, sorry, I was seeing if I had another example, but it looks like from here to here that the budget increased like 2 or 3 times, right? But actually, we're just going from about 19 or 20% up to about 23%. So it's not that big of a difference, right? I mean, there obviously is an increase, but sometimes people will not start at 0, which makes something looks like a much bigger increase or decrease than it really is. So you always want to check for that. And then here, how 2012 stacks up, they're talking about the warmest years on record, so possibly trying to talk to global warming or something like that. And so it looks like, just when we're looking at it, that wow, temperatures are really increasing. But then you notice that this is 1921, then we go to 1999, now we're back to 1934, and then we're back to 2006, but then back to 1998, and then so really, if we're looking this on a time series graph, we're going, here's 1921, we go up for 1934, and then we go uh, back up for 98, but back down in 99, then we're up in 2006, and then 2012. It's just kind of a weird way to look at it, so I don't think that would be the best way to show this. I would probably show this on a line graph if we're trying to show uh, change over time, which I guess is what they would be showing here. But all these would be considered bad graphs. So just think about making the data as easy as possible to read. So the graph may look boring to you, but we want it to just be clear to the reader, okay? Even though some of these up here look really fancy, it's very difficult for us to read. Okay? All right, so that's the end of chapter 2. And so chapter 1 and chapter 2 are both in our unit 1. So like I said, in this unit, really don't use your calculator very much. All you'll pretty much be using your calculator on is maybe when you're calculating frequency or relative frequency, you might use it some there. But we won't get into too much of the calculating stuff until chapter 3 and 4, which is our unit 2. So if you have any questions, be sure to email me at angela.galloway@kctcs.edu, and we will move into chapter 3 next time. Thanks.